Hi guys, my name is Thomas McGall, and today I'm going to be teaching you guys a little bit about web APIs. So if you guys have any questions during this workshop or after, feel free to reach out to us on the Hack Discord. Also, after this workshop, you can check out these slides at this URL right here. Also, we have a README available on GitHub that you can access at this link right here. This README will have a bit of an overview of what we covered today, as well as some of the code for our demo that we will be doing later. So let's get into it. First things first, what is an API? So API stands for Application Programming Interface. That might sound a little intimidating, but basically what that means is that an API is something that allows different programs to communicate with each other. So let's say we're writing one program and we want to use a different program that someone else wrote. APIs can help us communicate with that other program to help involve it in our own project. Specifically, APIs outline the rules for communication between programs. These rules can vary like from API to API, but usually they're standardized, and we will also be talking about that soon. So why should we use APIs? I kind of touched on this a little bit already, but basically it allows us to use other programs as resources for our own projects. So let's say we want to implement something in our project, but we don't have the knowledge or maybe the time to code that ourselves. APIs allow us to use other programs that other people have written, allowing us to add like a lot of functionality very easily by outsourcing requests for information and other tasks. So here I've listed a couple of APIs that are pretty useful, kind of give you an idea of what APIs can be used for. The first is Twitter API. The Twitter API is something that gives us information about tweets. So that's kind of information based. We have another one, responsive voice API. This is one that kind of provides more functionality rather than information. And let's say you have some text and you'd like your program to be able to read it back to you aloud. If you use the responsive voice API, you can do that very easily. Another one is the Open Weather Map API. This is another one that provides data about global weather. This kind of just sorry, let me check that we're recording. Okay. So the Open Weather Map API is another one that Open Weather Map API sorry, is another one that provides data about global weather. Just to give you a scope for like how massive and like how much information that these APIs can hold and also communicate with your program. These are just a few examples of APIs. There's thousands out there. If you're working on a project and you don't know how to do something, a good idea might be to look up if there's an API out there that you can use. If you Google cool APIs, there will be tons of results and you can look through those. So today we're going to be using a Pokemon API and a Google Maps API. So that'll be fun. So there's a very common type of API called a REST API. And REST APIs allow us to communicate with cloud-based servers through the internet. And online resources that use REST format are called RESTful web services. So that's something you might hear around. And a big benefit of these RESTful web services is that they are simplified and standardized. It's very easy to use them. It's very clear, the requests that you're making. And also it's pretty uniform across this whole category of RESTful web services, REST APIs. So when we're making requests to the API for information or something else, it's always in the form of an HTTP method when it comes to REST APIs. And when we make these requests, we are returned information in the form of a JSON object. So, or a JSON file. So we'll talk about what a JSON file is in a little bit. This diagram here is kind of in general, look at what REST APIs do and how they work. So these things right here that say get, post, put, delete, those are all HTTP methods. And we're going to talk about that in a second, exactly what those do. And then as you can see, it returns either JSON, it also says XML, and that's another type of file, but we're just going to be talking about JSON today because that's more common. So HTTP methods. We're going to talk about HTTP methods through an analogy of like an ACM coffee shop, right? So let's say you go to a coffee shop. In this case, like the barista will be the API that we're communicating with the coffee shop itself. So there's 4 main HTTP methods: get, post, put, and delete. Get, the first one, is used to read data. So for example, if we're at this coffee shop and we want information, we can ask, what drinks can I make? And maybe the API will tell us, oh, you can make coffee, drip coffee, a latte, stuff like that. So next is post, and post is used to create new data. Let's say it's full time and we want to add a new drink to the menu. We can use post or something like post to add a pumpkin spice latte to the menu. Sorry, that's a typo right there. The next method will be put. Put is used to update data. Let's say the bubble finally bursts and the economy collapses and we have to update the cost of our coffees. Oh no. We can use put to update the cost of our coffees, something like that. And the last method is called delete. Delete, obviously, as you can tell from the name, is used to delete data. Let's say we run out of espresso, or the coffee shop runs out of espresso. We can delete latte from the menu or the list of available drinks when that happens. So the next thing we're going to talk about is an API key. An API key is something that we use to identify ourselves when we are making a request to the API. So in order to use the API, we have to have a unique API key. This helps the API keep track of who is making what requests. Sometimes APIs will cost money. That can help them keep track of like bills. Also just, accountability. So as you can see here, this is me trying to use to explain this concept. But like, let's say we have a placeholder, my API key. Doesn't seem like it would be unique. But if we have a unique API key, that will allow us to use the API. And these keys will usually be provided to you by the API itself, either on like the platform or another way. So the next thing is endpoints, and endpoints are basically our point of contact for talking to these APIs. Different APIs will have different protocol for what they're expecting in their endpoints, but they all generally come in the form of like a link. This is kind of like a basic idea of what an endpoint would look like. Sometimes they have different like specific queries that they need, different inputs, different outputs. So here we have this link, Hack Coffee Shop, that's our coffee shop. And then let's say a lot of times we'll need to supply our key within the endpoint. So we'll do API key. Let's say my key is Thomas M. Realistically, it'd be something a lot less readable to be guaranteed that it's unique, but this is just an example. And then at the end right here, we have queries, or like basically what we're asking for, what we're looking for when we're talking to this API. So in our demo today, we're going to be using HTML and JavaScript. I forgot to mention that JavaScript and HTML are prerequisites for this course. But there's plenty of other workshops that Hack has done on HTML and JavaScript, specifically in HOTH. So if you guys are interested in learning those, or you want to continue with this workshop or follow along our demo, it might be useful to go and check out those workshops and then come back here once you're done with those. So when we're making GET requests in JavaScript, we do that using the fetch keyword. Here we have a variable that we've just created, response, and then fetch. And then right here inside of fetch, we put our endpoint. So the API, and then like in this case, the query is we're asking information about Ditto. And as you can see right here, we have this keyword await. You might be thinking, oh, what does that mean? Well, we'll get to that in a second. So another thing is that fetch returns an object that represents the HTTP request, but that contains a JSON. But in order to in order to deal with the JSON file itself, we'll need to extract it from that object. And we can do that using .json, as you can see right here. So we make the GET request here. We store in this variable response. This response is now holding an object. And in order to get the JSON out of it, we're going to do response.json and store it in our Pokemon variable. So I've been saying this word a lot, JSON, JSON files. What does this mean? So a JSON file stands for JavaScript Object Notation. It's a file that's used to store basic data structures that follows the general structure or outline of JavaScript objects. But to be clear, a JSON file is its own thing. And okay, so what the benefits of JSON files is that they're easily integratable with other languages. As you can see, it's pretty intuitive. It follows a pattern of key value pairs. Keys always have to be strings, but their values can be pretty much anything. They can be ints, doubles, booleans. They can even be other JSONs as well. So that's what we have here. This is a key, drinks, and then we have another JSON of set of key value pairs. Latte is $4.50, coffee is $3, et cetera, et cetera, et cetera. So a nice thing about JSON files is that we can easily access and edit them. There's a couple ways we can do this, including using dot notation and bracket notation. Just a quick example right here. We have our JSON hack cafe, and then we want to go to drinks, latte, and then update the price of a latte to 5. Let's say we want Jody to clock in. So here it's like Jody is clocked out, and we want to change that to true. And we can do that also using bracket notation. So we'll do hack cafe dot baristas, and then put in the key of Jody, and then we can set that to true. So as we saw before in one of the earlier slides, we had that await keyword. We'll talk now a little bit about what that means. When we're making HTTP requests and other API requests, it's important to use asynchronous functions. Well, what does asynchronous mean? An asynchronous function is something that allows our program to continue without needing to be finished first. So basically, usually our programs run from top to bottom, and once one thing is finished, it'll go into the next and the next and the next, etc. But let's say we want to make a GET request, and that might take a while. Well, asynchronous functions will allow our program to know that this function is asynchronous, and it will continue to run while this one GET request runs in the background. And we can indicate asynchronous functions by using the async keyword. And if we put async in front of function header, it'll be clear that to our program that that function is asynchronous. And in asynchronous functions, it's usually paired with another keyword called await, which is what we saw earlier. And the await keyword indicates what within our asynchronous function we are waiting for to complete before we can continue within the asynchronous function. So it's awaiting, if we're doing a GET request inside of our asynchronous function, it might be waiting for like the fetch request to complete. And then once it does that, it might do something else. So let's take a quick look at an example of this. So this is a asynchronous function that we have here. It's going to say hi twice, but the second time it says hi will be 2 seconds after the first time. So we have this asynchronous function. It's going to say hi. And then this function that we hear, say hi after 2 seconds, let's just assume that that's exactly what it does. It's going to say hi, but first it's going to take 2 seconds to complete that function call. And once that function is complete, it's going to set second greeting to hi again. And then it will log that second greeting. What the await keyword does here is it's going to start this function. And then when the function concludes, which will be after 2 seconds, it will store that, it will store the return string, which will be hi again, into second greeting variable. And then it will print that hi again to the console once that's done. And basically, since this function is asynchronous, it will run in the background of our program. So if there's something above this and something below this, whatever's below won't necessarily need to wait for this to complete before whatever happens below. It'll log after this is complete. So let's get started on our first demo. Today we're going to be using Pokemon API. And yeah, let's get right to it. So here we have our Pokemon API. As you can see, this is a RESTful API, which means it uses the general format and standard that I outlined earlier in this workshop. So let's take a look. Usually APIs will have like a website or something like this that tells you how to use them. So let's take a look right here. Right here we have our endpoint, HTTP Poke API.co. And then right here at the end, we see we have our query. So it's asking within Pokemon, which Pokemon do we want? We want to look at Ditto. And then what the API will return to us once we make this API call is this JSON file right here. So you see we have all this information, abilities, forms, items, moves, all this stuff. So what we want to use today, we have all this information. We're not going to use all of it, but let's say we want to write a program that is able to give us images or links to these images of whatever Pokemon that we want. So let's get to it. Here we have a basic boilerplate template for an HTML website. Once again, if any of this doesn't look familiar to you, feel free to check out Hack's other workshops on HTML and web development. We have plenty of series and workshops, so feel free to check those out. And yeah, so let's get into it. So make a script tag, and then let's write a function that makes a request to this Pokemon API. So remember, since we're making a request, we want this function to be asynchronous. So async function. And let's call this function get Pokemon image. So we're going to make a request to this API and we want to store it in a variable. So let's say constant response. And then we're going to do fetch. And then remember, when we use fetch, we want to put the endpoint inside of as a parameter to the fetch. So if we go back up here, this is the endpoint. So we'll just take that and we will copy it in there. Needs to be a string. So we have that. And remember, since this is a asynchronous function and this is a fetch and we want fetch, and fetch might take a while, we want to use the await keyword to indicate that we're waiting for this fetch get request to complete. And then once that's complete, it'll store in this variable and continue with our asynchronous function. So now that we have this object stored in our response variable, remember, we need to convert it to a JSON file that we can easily interact with. So let's create another variable called Pokemon. And let's do response.json. So this is something that also might take some time. So we're going to use the await keyword again. And now we have an object that, a JSON file that looks like this stored in our Pokemon variable. So since the point of this function is to get a URL for a Pokemon image, let's return Pokemon. And then let's try to find the image of this, or the URL for this image within our Pokemon JSON. So if we go back to the APA website, as you can see here, this is an example of what a Pokemon's JSON file might look like. And since we're really only interested in images, as I said before, let's go to Pokemon. And then if we want to get to this right here, we have to do Pokemon.sprites and then .front default. So let's go back to our code and we'll do return Pokemon.sprites front. So just to make sure that we're doing this all properly, let's also print this out to the console to make sure that we're getting a valid image URL. So we'll do console.log, and then the same thing that we have down here. So let's copy that. And now, if we save that and we run our code and we check the console, oh, sorry, I forgot to run the function. So let's make sure we run the function, get Pokemon image. Now we get an image URL for a Pokemon. So if we click on that, look, we get a nice sprite for our Ditto. Just to like remind you guys how endpoints work and how we specify the data we want to look for. Let's say we don't want Ditto, but let's say we want a different Pokemon, say Lugia. That's my favorite Pokemon. If we go back to, if we go back to our HTML page and we refresh it, look, we have a new image, and this one's Lugia. Isn't that so cool? Okay, so that's the first part of our demo. And we will now move on to the second part of our demo. And the second part of our demo will involve taking all these Pokemon sprites and then using it to create something like a Pokemon Go map. So by the end of this demo, we'll have a product that looks something like this. And you might be thinking, well, where do we get a map? How are we going to make this map? We're going to use another API. This time we're going to be using the Google Maps API for JavaScript. And that's going to give us a map, and that's going to allow us to place markers like these using our Pokemon images that we did previously and place them on the map. So let's set that up. So the first thing we have to do is we have to go to the Google Maps developer platform and create an account. And once you have an account, so if you go to, I think it's developers.google.com maps. So you'll get to a page that looks like this. I'm already signed in, but if you don't have a Google developers account, you might want to create one. Once you created one, you can then click get started. Let's open up the docs as well. We'll need those a little bit later, but let's click get started. And it'll take you to a page that looks like this. So a great thing about a lot of Google APIs is that they give you a small budget that allows them to be free. And they really only start costing money when you're using them on a larger scale. So I think they give you around, I think, $200 worth of free content, and then it starts, you start getting charged. So you will need to connect a credit card to your developer account in order to create a functioning project, but you won't get charged, and I think it will notify you before you do get charged. So let's get started. First thing we'll do is we'll make a new project. So these are a couple of projects that I've worked on. This was from my run through, and I will create a new project. So let's click create new project. What do we want this to be called? I'm going to name this one Pokemon Go map. And you don't need an organization, I don't believe. Create. And now we have, let's switch to our new project. So now we're at Pokemon Go. We're in our project. So there's all these different APIs that we have. Google has so many, but the one that we're going to be using today is called the Maps JavaScript API. So let's take a look at that one. And you're going to want to enable this specific API for this project. So we're going to click enable. And we'll wait a second for that to complete. And now it's enabled for our project. Let's go. So now we have our API. Well, how are we going to use this? We need an API key to be able to access this API. So we'll go to credentials. And right now you can see we don't have any API keys. Let's create one. So click on create credentials, API key, and boom, now we have a new API key. So let's copy that. You can restrict your keys to prevent people you don't know from using them and getting your credit card charged. If this was a key that I was planning on use, this like showing you guys this key would be a bad idea because then you guys could use it and I'd get charged, but I will be deleting this later. So there's no need to worry about that. But rule of thumb, try to keep your API keys private. If you're working on a project and you upload it to GitHub or something, that might be an issue because then people can see it and use it. So yeah, try to keep your API keys private. So let's copy our API key, and now we can close this and we have our API key. Yeah, so now we have all the things that we need to start coding. So let's get to it. Let's start setting up our Google map. So let's go back to our website. And now we're going to be creating map. So first thing we're going to need to do is we're going to create, we're going to do a div tag, and we're going to give it the ID of map. This will be the HTML element that is our actual map. So, so let's give it an ID of map. Awesome. So we have our map, but it doesn't know the dimensions for the map, like what we want to look at. Eventually, when we try to load our map, this will create issues. So let's just specify now. We want our map to have a certain, we need to specify like the dimensions of our map element. So we'll do map, and then we'll give it a height of 400 pixels, and width of, let's say, the entire screen, so we'll do 100%. So this right here is CSS for styling. If you don't recognize this, we probably have another workshop out there for CSS styling. And you can check that out and then come back here. So, but this is all the styling we're going to do for now. So if you don't want to, go watch that workshop now, you can just copy this and we'll continue with our demo. So now we have our map. There's a few other things we need to do before this map will actually populate within our web page. So let's do it on the script tag. And in order for our map to work, we need to have an initialization function. That's something that the Google Maps API needs. So let's give it one. Once again, this is using an API, so we're going to be using an asynchronous function, and this function will be an initialization for the map. So it's going to need to be called init map. And I misspelled function. I'm so bad typing. And now we have our function. And the way we're going to do this is we're going to create a variable to hold our map. And we're going to do new Google .maps .map, and then we're going to do document .get element by ID. This might be a little bit confusing, but basically what I'm doing, so I'm gonna, here, I'll give it, so it's getting the HTML element by its ID, so the ID of map, so do map. And then it needs one other parameter, which is general settings for our map. So we'll give it, it's going to need to know how much zoom we want. So let's say 3. It's pretty far out, but it works. And then we'll give it a center of, and then we need to give it another object that has a latitude and longitude. And we'll give it, let's get the latitude and longitude of Westwood, which is where I'm at right now. Westwood, LA coordinates. So latitude will be 34, and the longitude LNG. That's how we're going to specify it, will be this. Cool. So it's actually west, so we're going to need to make that negative. It only accepts latitude and longitude between 0 and 180. So south will have a negative value, as well as west will also have a negative value. Okay, so what are we missing? The thing we're missing is we haven't indicated to our program where we're making these calls to. So we can indicate that to our program using another script tag. And then inside of our script tag, we'll specify the source to be the endpoint that we're making these calls to. So we talked a little bit before about how endpoints look different based on different APIs. They have different protocols, different parameters that they're looking for. So you might be thinking, well, what does a Google Maps API endpoint look like? And we can figure that out by taking a look at some of the Google Maps documentation. So if we go back to the Google Maps platform, and this is where we enabled our Maps JavaScript API previously. If we go to the documentation, and then we scroll down a little bit, we can just click on any of these because they'll all have this source tag. We can scroll down, and then it has right here an example of what one of these endpoints would look like. So we'll just copy this, and we'll go back to our program, and we'll paste that right there. If you look closely at this, you'll see that there's currently a placeholder where it says your API key. Obviously, we're going to want to use our unique API key that we got earlier. So let's go back to where we were before. And remember, our API key is stored in our credentials. So we'll go back there, and here we have our API key that we got earlier. So we'll copy that, and then just put it in right here where it says your API key. We'll save that. And now, if we run that, let's see. Oh, okay. So quick typo here. We're getting rid of that space. And now if we run that, we have our map. Yay. So we have our map. Our calls to the Google Map API work. What do we do next? So the next thing we want to do is you want to populate this map with a bunch of Pokemon sprites. So let's go back to our program. Currently, we have this get Pokemon image function, but right now it only gives us one type of Pokemon image. Let's try to make it so that it'll give us a random Pokemon image. The Poke API that we're using actually does not have a random, have an endpoint, have a query that will supply us with the random Pokemon. So let's try to find another way to do that. So if we go back to the Poke API, you will see that we can also format our queries by indicating Pokemon and then the Pokemon number that we want. So I don't know how familiar you guys are with Pokemon, but in the Pokédex, which is like the dictionary of all the Pokemon, each Pokemon has its own number. So we can generate a random number and then put that into this query using string interpolation, which basically means just taking a variable and then putting it into our string. So first, let's generate a random number that will be useful to us. So let's call it Pokemon index. And we're going to use something called like math.random. And then, so math.random is a bit confusing. It generates a random double in between 0 and 1, but we want our numbers to be in between 0 and 150, which is like how many original Pokemon there are. So we'll multiply that by 150. And then we will add 1 because we don't want it to be 0. And we'll for that so we get an integer because this will return us a double. So now we have that. And we're going to do something here called string interpolation. I talked about that earlier a little bit. It's a very useful topic. I won't go too in depth into it right now, but basically it'll allow us to take this variable and then work it into this string that right here where we're making our fetch request. So we can do that by doing brackets and then put a $sign in front of that. And we have to use these types of quotes. So now if we put in Pokemon index, we will get a random Pokemon image. So this time it's this one. If we refresh it, Zubat, cool, fun. So now we have random Pokemon images. And the next thing we need to do is we're going to be adding markers to our map. So if you guys have ever used Maps, Google Maps before, you might know they have like these like red pins that you can drop on the map. And we're going to be adding pins like those, but instead we're going to use our Pokemon images as their icons. So how can we add a marker to our map? Let's learn how to do that. So the way we add a marker is kind of similar to how we initialize our map. Do it inside of our initialization function, and we'll do let marker equals new Google dot maps dot marker and the marker takes the parameter of some settings, so it needs its position, and that will be set to another object using latitude and longitude. So lat, we'll just do the center of our map. So we'll do, for now, we'll just set it to westward as well. And we also need to specify the map that it's on. So our map is called map. So we'll just do map equals map. And now, if we save that, you can see that we have a marker right where we are right now. So let's try to change that to have an icon of a Pokemon. So we can also specify the icon that we want it to be. So we'll do icon, and then we'll do URL of, and then we can call our function, so get Pokemon image. And then we will just specify its size, so scaled size. And then we'll do height 75 and width also 75. Save that. Probably URL, not a string. So, okay, so we'll do we have to make sure that this is a function, and now not a string. Oh, okay. We have to do await again to make sure that it still works. And now we have a random Pokemon as our marker. And if we refresh it, it's a different Pokemon every single time. So instead of only having one Pokemon, let's have a whole bunch of Pokemon. And we can do that by creating a bunch of different markers. So let's do that by creating a for loop that creates a bunch of different markers for all of our Pokemon. So when I equals 0, so let's say we want 100 Pokemon, and we'll create 100 different markers. So the first thing we'll do, let's create a variable for our image URL. So Pokemon picture, set that to await, and then our Pokemon image. The next thing we'll do is we will actually create our marker. So marker equals, and then we'll copy this syntax right here. So Google Maps marker. The position right now is in one fixed location, but why don't we change that to be something random? And then for our URL, we can also just change that to Pokemon picture now. So once again, we're going to use math.random to give it a random latitude and longitude that's within, let's just say, the domain of the United States. So I already did this math. I don't want to bore you guys with the details, but I'll just type it out right now and kind of try to explain it to you. So latitude will be 33.8 plus math.floor. Then we'll do random 12,000, 1,200 divided by 100. So basically 33.8 is the lower left, the latitude of the lower left corner of the United States. And then I'm adding a random amount between 0 and 12 degrees of latitude to this. So it's going to give us a random X in between the left and the right side of the United States. And we'll do the same thing with longitude. So we'll do 118.4 plus 4 random 3,600 divided by 100. And now, if we run that, we get a bunch of Pokemon populating our map. And as you can see, they're spawning in over time, but because they're all asynchronous functions, they're able to complete on their own time. So now we have this map, kind of looks like Pokemon Go, kind of fun. And yeah, that's it. That's the demo. So if you guys have any questions about anything I've gone over today, feel free to ask in the Hack Discord. And yeah, I hope you guys have a nice day. Thank you for coming. Bye, guys.